Hi, I'm Nathan Lively from Sound Design Live, and today I'd like to talk to you about parametric filters. How do we use them? How do we know what their gain and bandwidth needs to be so that we get the correct results? And how can we figure that out relatively quickly so that we're not just like kind of sweeping around for a long time trying to find the right shape we want? So I'm talking about this because I have a workshop coming up in a week called How Do I EQ My Speakers? And I'm going to put a link to that in the chat right now in case you're interested in taking a look at that. And if you're here watching with me today, I would love it if you would type your name into the chat. So I'm Nathan and I'm in Minneapolis. Okay. So imagine that you've taken a measurement like this and you've got your target set up. This is your favorite target and you've got your measurement and you say, okay, I've done everything I need to do up until this point and now I have one last thing. Obviously, I need to take care of this peak right here. It doesn't sound good. It doesn't look good. Let's take care of it. So I think the gain is pretty clear, right? So the peak is at 9.3 dB, so we need a filter that is minus 9 dB. But then what is the width? How do I know what the bandwidth is here? Well, the first thing that could be helpful is to change your frequency scale to octaves. And now every octave we have a vertical line, so 250 times 2 is 500, 500 times 2 is 1000, etc., etc. And so we're looking at this and we're saying, okay, great. So now what's the bandwidth? Is this one octave? Well, what am I looking at? Well, I want this filter to basically start here and then stop here. So maybe that's what I should do. So I'll say, okay, I'm going to start here at like 350, 360, and then I wanted to stop here at about 5K. So if we look at this span now, this looks like about 1, 2, 3, 3.5 octaves. So it looks like I need a 3.5 octave wide filter to make this work. So let's try that. So I have exported this measurement and I have imported in here to Crosslight so that we can play around with some filters and do some simulations. So I have the same thing here, same measurement, same target. So let's try that filter. So what did I say? I said 3.5 octaves, bandwidth of 3.5, and it's centered around 1.3 kilohertz. Let's insert that. Wow, that's way too much. Why didn't that work? Okay, so now we could just play around with it and we can say, okay, that's obviously too wide, so what about 3, 2, 1, 0.5? That seems a little bit closer. So how could I have gotten there faster? Well, let's actually measure this filter and see what's happening with this filter. So I'll switch over to just measuring the electrical response. I'll hide my target and let's get rid of this gain that I have here. So now the filter is starting here at 0 and then it goes down to -9. Let's actually go make it go down to -10 to make the math a little bit easier. Okay, so this point is at -10. And so what can we know about this? Well, let's actually change this to 1 octave wide. And let's put in some cursors here. And let's make those cursors 1 octave wide. So we know that an octave could be about 1000 hertz times 2 is 2000 hertz. And we can lock these together. So these lines now are showing us 1 octave. And so now if I move these so that the peak is right in the center there, then what's interesting to see is that this is at minus 10. And now this octave-wide bandwidth is actually marking 3 dB down from minus 10. So I think I was confusing myself at first. Remember when we started here, I said, oh, I want the filter to start here and stop here. That's not really what defines the filter. In terms of bandwidth, what defines the filter is the 3 dB down point from the peak. So that's really what I need to be looking at. So let's start over. Let's bypass this filter. Let's go back to looking at our response here. Let's turn back on our target, and I need to put that gain back in that I took off. There we go. Okay. And here's what we want to do. Let's try this. Let's put this cursor on top of this peak. I'll unlink these. And now let's try to find the minus 3 dB down point. So I'm just going to be looking over here at these delta values. So I'm moving this cursor until this cursor is 3 decibels lower than this cursor. Okay, and I found it. And so now I'm going to move this cursor so that it lines up with this guy. So basically now I've surrounded this area where I have this peak. I'm going to zoom in a little bit. I have my peak here, and now I have my 3 dB down points here. And now we could take these values, 1091 and 1624, 1091 and 1624, and now we could calculate the bandwidth, and we can say, oh, it's actually about half an octave, and so we could put that in, but I don't want to have to do that every time in the field. I want to be able to move quickly. So this may be a fast way for you to do it. You could just have the calculator open and figure this out. But I think it's almost just as easy to just look at these. Let's go back to Smart, since this is where I was showing you the octaves, right? We take a look at these octaves and we can basically just say, is it equal to an octave or not an octave? Is it bigger or smaller than an octave? So looking at these points here, let me draw the octave in. So here is 1000. Here is 2000. And so if we look at our 3 dB down points here, we can see that this is less than an octave. So that's all I really want to share with you in this video, is that when you have your frequency scale set up in octaves, then you can pretty quickly look at where is the peak, where is the minus 3 dB down point, and say that, oh, that's less than an octave or more than an octave. And then at least you have a starting filter that is much closer to where you need to be than if you just guessed, probably. Now, eventually you do this so much that you get to where you can just kind of look at it, look at the response, and know about the size filter you need to put in. But this helps me looking at these vertical lines here and just thinking about, is it less than an octave or more than an octave? Okay, so let's try this. So we see that this is less than an octave, but we don't know by how much. So let's try half an octave. So back over here on my filter settings, I'm going to leave the center, the peak, at 1.3 kilohertz, but instead of 1 octave, let's change this to half an octave, and instead of minus 10, let's change this to minus 9. I'll put this filter back in, and there we go. Much better, right? And just to remind you, where we started was here, and we were cutting way too much. And so just moving quickly here, I might say, great, that's fine, but this didn't hit this section as much as I wanted, and didn't hit this section as much as I wanted. So let's see if we can move forward with just this question of bigger or smaller than an octave, and see if this can help us. So let's use the same process here. I'll put this guy on the next peak that I might want to hit, and then I'll try to find the minus 3 dB down point over here. It'd be nice if it ended up right on this peak. Okay, there's minus 3 dB. Oh, let me do a little bit better. Okay, so I could go either way. I could say that's minus 3 dB, or I could go over here and say that's minus 3 dB. So let's actually try that first. And I'll do the same thing over here where I find the other side. So I'm just looking for each side here. And now the question, is it less or more than an octave? Well, here's 2000 and here's 4000. Let me draw those lines again to make this more clear. Here's 2000, here's 4000. Well, my markers here are within an octave, so I'm not above an octave, somewhere below an octave. So let's try something like 0.7. So let's put a filter here at around 2.6K, 0.7, and this is at plus 4, so let's try minus 4. And we'll insert that, and that looks pretty good. And now, if I wanted to, I could grab this filter, move it around a little bit, see if I can find, a nice balance here. And let's do one more together. Using the same process, let's put this on the next peak I might want to hit. And now we're going to run into a problem, right? Because nowhere here is there going to be a minus 3 dB, because this is going to end up being a 3 dB filter we need to put in here, a 3 dB correction. Nowhere in here is there a place that's minus 3. So this is where the calculation of bandwidth starts to fall apart. And this is why you'll see some processors that prefer something like dB over 2, right? I haven't run into those very much. Most of the processors I'm working with are still using Q or bandwidth, so that's why I'm talking about bandwidth today. So what happens when you have a filter that is 3 dB or less than 3 dB? Let's go back to measuring our filters so we can see what that is. I'll take the gain off of here again. And let's just put a filter down here at like 200 Hertz. I'll just use this one over here. Bandwidth 200, 1 octave, minus 3. And let's reset our cursors so that they are 1 octave wide again. And I'll lock them together. And I'll move them around until I find that they are centered around this filter. There we go. So now what is the point? So this is minus 3. That's where I have this filter set. It's a minus 3 dB filter. So now where did these guys end up? This should be an octave wide filter, but they're not at the minus 3 dB point like they were with this guy and this guy. Now they're at minus 2. I'm sorry, this is a cut filter minus 3. Now we're at minus 2, so we're at the minus 1 dB point. So I don't know the math of how all of this works, but I do know now that if I have a filter that is minus 3, then these cursors or this bandwidth is going to be around 1 dB down, not 3 dB down. Okay, I hope that helps. I hope this is not more confusing, but let's go back and try inserting a filter. So I'll bypass this filter. Let's go back to looking at the response. Let's zoom back out. Let's put that gain back in that I removed earlier. And let's go back to trying to attack this peak here. So I put this guy in the peak, I unlink these, and now instead of trying to find the minus 3 dB point, let's try to find minus 1. So this is going to be pretty close in, so let's zoom in a little bit. So there's 2, there's minus 1. And I wonder if maybe we could jump over and hit this peak instead. Yeah, I like that a little bit better. So you can't see where my eyes are looking. I'm looking at this delta value here. Okay, there we go. So you know the next question I'm going to ask, is this more than an octave or less than an octave? Well, this vertical line is at 400 hertz. So then an octave would be at 800 hertz. So here's 400, and where is 800? It's right here. So are my red and blue lines here more or less than an octave? Well, they're a lot less, right? So probably even less than half of an octave, probably closer to 0.4, 0.3. So let's try 0.4. Let's keep the peak at 500 hertz, and we'll try a bandwidth of 0.4 and a gain of -3. So I put that in, and that works pretty well. Now I would need to make this a little bit wider if I want to try to hit this peak, but then that's also going to make, I like how nicely this worked out. So let's see if it's a little bit bigger, 0.5. Okay, maybe that's a better compromise because now I've reduced this peak a little bit and that one's there. Okay, I don't want to micromanage too much. This looks a lot better than when we started. So let's bypass this entire tab. Bypass. There we go. There's that giant peak that I thought maybe I could just hit with one filter, and it turned out that I needed 3. Let's activate this tab, and remember, I don't need this one here. There we go. So if I were to do one more, I might do this area here, but that's being really picky at this point. And I don't know if I'm so much EQing this and teaching EQ. Really what I'm trying to do is just study parametric filters and see how does a parametric filter work? What are its characteristics? And then how can I use that to quickly estimate them in the field when I think I might need them? So just to wrap up some of the things that I'm learning as I'm reviewing these things and trying to insert filters and trying to make this work. If I'm using bandwidth as the design agent of the width of the filter, then what I'm going to do to quickly figure that out is look at the peak and then find us the -3 dB down point and then see is that bigger than an octave or smaller than an octave. And the way I can figure that out quickly is by looking at these vertical lines here, and then if you're in Smart, you can set up your settings here so that the frequency scale is actually in octaves, and you can quickly look at that. But in cases where it might be a filter that is lower than 3 dB, the gain is less than 3 dB, then I'm not going to be looking for a -3 dB point. I'm going to be looking for something more like the -1 dB point down from that peak. Okay, so I hope this has been helpful for you. If you're watching this and you have some ideas for me, I would love for you to put them in the chat, put them in the comments for this video. And if you have any questions about this, also please let me know. And I just want to remind you one more time that I have this workshop coming up in a week. It's called How Do I EQ My Speakers? When you get to this page, you'll see that when you scroll down, there are 3 available times, 2 on Sunday and 1 on Monday. So there's a time here that's even available for the Australians. So I hope you'll join me. And yeah, thanks for watching my video. All right.